Hello everyone. Today we are going to solve question number 26 of LeetCode. Remove duplicate from sorted array. In this question, we'll be given an array which is sorted. Okay. What we have to do is we have to uh, first of all we have to give two outputs in this, right? First one will be the number of unique elements inside this nums. The second will be we have to modify this nums in place. Okay, we cannot create a new array. Okay, we have to modify this in place to get a final outcome like this. Okay, so let me show you this example. This is nums. Okay, 1 1 2. What we have to do is we have to remove this one and we have to bring this 2 forward to it. Okay, like this. So one of the output will be 2 as number of unique elements are this 2 and the rest can be garbage. It doesn't really matter to the custom touch. Okay, what we have to do is we can use multiple approaches to solve this question. Okay, uh first thing that comes in my mind, uh for unique are set. Okay, you can just store a set, you can just use a set and store everything inside it, and then we can just send set dots s dot size or set dot size, whatever the name is. Okay, let's code that part and then we can proceed to know more methods. Okay, so let's this one quickly. Int s, and we have to store from nums dot again nums dot end. Okay, we have stored all unique elements inside this one, and now what we have to do is we have to iterate over the set. Okay, for int x given s nums of, okay, we have to iterate over array 2. So int I equals 0, I plus plus is equal to x. So all the starting elements inside this nums will be stored through the variables which were unique. Okay, set stored all the unique ones, and we've filled all the starting nums uh, with this set values. Okay, so and the final thing that we have to return is the number of unique elements. That will be return s dot size. This will return the number of unique elements inside the set, this the nums in. Okay, this one, this one is, and let's submit this. Solved. All the time complexity wise it's bad. The next method, what we can do is we can just use a vector in place of this. Okay, so what we can do is I have drawn this board for you. The brute force approach that we will be trying to use is we can just store the same way as we stored a set, we can store a unique. Okay, we can store this as this is also a vector. Okay, we can store a new vector, we can just iterate and fill it uniquely. We have to iterate over this, and as soon as we hit a unique element we can just store it. It's only possible because this array is sorted. Okay, so once this array is sorted, uh, when we move from here to here, we just have to check the adjacent one, as if the adjacent one are not equal, then the element is obviously unique, because since it's sorted, both of the duplicate elements will be beside each other. Okay, and then what we can do is we can reiterate this unique to fill the original values, like this final one I have drawn over here. So unique 1 2 3, 1 2 3 is filled over here, and the 2 3 remain as same garbage. The modification is not needed. Okay, and the final thing that we have to return is unique dot size for the number of unique elements inside this array. Okay, so let's code this one. So we need a vector int unique. Okay, and another thing that we want is we can just push the first element. Okay, one thing to notice is the first element is always unique. So once we push this, we can just compare it with the next one, the next one. Okay, so let's push the first element. E dot push back thumbs of 0 is the first element. I push the first elements. Now we'll iterate over the rest of the element. Okay? We can iterate over the rest of element. For int j equals 1, j less than thumbs dot size j plus plus. If nums of j is not equal to dot back. Okay, unique dot back will check the latest element inside. Like here we have the latest element. Forget this part. The latest element here will be 1, or in this case the latest element here will be 3. The last element is push dot unique dot back. Okay, if it's not equal, that means we have a unique element in our hand. Okay, so what we'll do is we'll just unique dot push back thumbs of j. Okay, we'll push this, and what you're left with is the same array. Okay, the same thing is left with you now. Now what we have to do is we can just fill original nums, this original nums with the unique part. Okay, so can do is int I equals 0, I less than unique dot size I plus plus nums of I equal to unique of I. We have filled this part. Now the thing what we have to do is we have to just return the number of unique elements. Return int dot size. Okay, so we can return this part, and this is already modified using this for loop. Okay, so this one also has time complexity of O of n, O of n. Okay, let's run this one. It's accepted. Now let's submit this, and it's submitted. We have, this is like O of n. So the best time wise, the best case scenario for this question is O of n, and because we have used an extra place to store unique elements, hence the memory is quite bad. Okay, now what we have to do is we have to learn a new method which is called two pointer. Okay, so what two pointer method says is, let me take you directly to two pointer method. Okay, so here what we are going to do is we'll have an index I equal to 0. We know that the first one will be unique. We'll iterate from this to this part. Okay, and once we check these two and we have a duplicate, uh, then we'll skip it. Okay, if we have a duplicate, we'll skip it. If they are different, then we'll modify it. Okay, so the I will be like all the elements behind I are unique. Okay, there's no duplicate behind I, and j will be traversing the whole array after I, and it will grab all the unique elements and place it uh, in front of I. Okay, so I have a dry run for you over here. So let's say we have this nums of array same as this one. Okay, what we can do is we have defined I is equal to 0, so the first element if all, already unique. Now we traverse from j is equal to 1 to n. We can see j is equal to 1, 1 is equal to 1. Okay, 1 is equal to 1. So we have to skip this one. Now we check for j equal to 2. For nums of 2 is 2 and nums of 0 is nums of 0 is equal to 1. So this is a unique element case. So what you have to do is you have to first one we have to uh, push I friend I forward like I plus plus. Okay, so we'll get I is equal to 1, and then we have to fill it with the unique element. Okay, now we have 2, and we can see we have 2 over here, so we have to skip this one. Then we have 3, and 3 is different from 2, so we have to first I plus plus, and then we have to fill the nums with the unique element. Okay, so the result will be something like this, or something like this. Okay, uh, this is also the same thing, and we'll discuss this afterward. Okay, and this is the preferred approach to solve this question. Okay, so let's code this part, and then we'll discuss how we can return the number of unique elements. Okay. So let's check with how we can iterate over it. So let's build a utility int n is equal to nums dot size, int I equals 0. We know the first element is unique. Now we have to traverse some for int j equals 1, j less than n, j plus plus, if nums of I is not equal to nums of j, then what we have to do is j plus I plus plus, we have to I plus, then we have to we have to fill this nums of I with nums of j. So we have to fill it with the unique element. Okay, and after this whole part, the only last thing that will be remaining is how we can uh, find how many number of unique elements were there. Okay, so we can come over here and see first iteration I is equal to 0, j is equal to 0, j is equal to 0 is never present. Sorry. So j is equal to 1, I is equal to 0 currently. We compare this one, we compare this part, this one with this one, we say they are the same, they are duplicate, so we just j plus plus, we just skip. Okay, I can just write here skip if 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 duplicate. Okay, skip if duplicate. Then next part, j for iteration j equal to 2, we have 2, and we have 1 over here, they are not equal. So what we have to do is we have to first I plus plus put here, and then we have to fill this one with 2, right? We have to fill this one with. Okay, now we have I over 1 over here, and then for the next iteration we'll see as element is equal to 2. So nums of I is equal to nums of j, nums of I is equal to nums of j. So we'll skip this one. And the next part, for j is equal to 4, we have 3. So nums of I is not equal to nums of j. So this time we'll I plus plus first, and then I plus plus first, and this one will be filled with 3. Okay. This one will be filled with 3. So this way we have modified our answer. So our I reached till 2. We know the number of elements which are unique as this, and this. So we have to return I plus 1 as number of unique elements. Okay. So we have to return I plus 1 as number of unique elements. Okay. Time will be n, space will be O of 1, because we only used I and j. Okay. So let's submit this one. This one beats the time complexity. Okay. So this is the most preferred solution for this question. Okay. So thank you for watching.